Hi, it's Miss McGuire, and we're going to jump right into our very first Algebra 2 lesson. So today, if you were able to print a copy of these guided notes, they are on Schoology. You're more than welcome to print it out if you have a printer at home and follow along. If not, then you need to be doing this on notebook paper, or graph paper is okay. On graph paper, you need to make sure you're writing dark enough that I'll be able to see your notes when you submit a picture of them to Schoology later this week. So if you are writing this on notebook paper, then you need to organize your information in a similar way to the guided notes. By that, I don't mean that you absolutely have to have like all these tables and things. Just make sure stuff is labeled. Like make sure things are labeled example 1. Make sure you have the topic and the objective labeled. At the very top of your notes, you also need to make sure that you have your name first and last. So you're going to put your first and last name. At the top right-hand corner of your notes, you're going to put the period. So I'm going to put 0 period just for fun. And you also need to put the date. So today's either the 19th or the 20th, depending on which period you're in. So today we are on Unit 1, Lesson 1. So you're going to want to make sure that in your handwritten notes you have these notes labeled Unit 1, Lesson 1. And the topic today is solving multi-step equations. And for this school year, for distance learning, you are going to have to write down the objective of the day, because I need to make sure that you understand what it is that we're trying to learn today. So today's objective is I will be able to solve multi-step equations by using inverse operations. So inverse operations are kind of like opposite operations. They like cancel each other out. So for example, to cancel addition, we would use subtraction. To cancel multiplication, we're going to use division, and vice versa for both of those. So looking at example 1, we have 3 times x minus 1 is equal to 2x plus 9. So parentheses in math always mean, I didn't realize my highlighter was that big. Just a second, let me fix that. So parentheses in math always mean multiplication. So what this means is you're going to take this 3 and you're going to distribute it to the x and the -1. You're going to multiply. So 3 times x is 3x. 3 times -1 is -3 equals, and then we didn't change the right side of the equation. So you might notice that we have an equal sign with 2 sides of the equation. And sometimes it helps kids if we draw a line through the equal sign and just show that there are 2 sides of the equation. What you do to one side of the equation, you have to do to the other. So my main goal in solving an equation is to isolate the variable. I want the variable on one side of the equation. So it doesn't matter if it's the left or the right, but in this case, I'm going to move this 2x to the left side. It's positive, so to cancel it, I'm going to subtract it. So 3x minus 2x becomes 1x, or just x. We didn't do anything with the -3, so we leave it alone. 2x minus 2x on the right side cancels, it becomes 0. And then we want to bring the positive 9 down. Now, the only thing keeping the x from being alone on the left side is that -3. How do I cancel -3? I add 3 to both sides. So x is equal to 12. All right, And then we can double check to make sure that we're right by just plugging it in. So 3 times x minus 1 is equal to 2x plus 9. I'm going to replace the x with a 12. So 12 minus 1 is 11. 2 times 12 is 24. 3 times 11 is 33. 24 plus 9 is 33. Is 33 equal to 33? Yes, so we're good to go. So this example also has an extra question though. What does it mean for an equation to have? Well, this equation has exactly one solution. What does it mean for this equation to have one solution? So the solution we found is x equals 12. And for x equals 12, that means that x can only equal 12. So it means that there is only one value that makes this equation true. So there is only one value, 12, that will make this equation true. But for another equation, it could be a completely different number. In this case, x was equal to 12, so that value is 12. All right, let's go ahead and move on to example 2. So for example 2, we have another equation with distribution. So we're going to take this negative 2 and distribute it. And negative 2 times y is negative 2y. Negative 2 times 1 is negative 2. Negative 2y plus 5. And then if you do like dividing the equation by the equal sign so you can clearly see the sides and go back and forth between the sides, then that's perfectly fine for you to do that. So now, again, we want to make sure that all the variables are on the same side. So I'm going to move this negative 2y by adding it to the other side of the equation, to the right side. So negative 2y plus 2y cancels on this side. I'm left with negative 2 is equal to. And then on the right-hand side, negative 2y plus 2y also cancels, or gets me 0. So then I'm left with this 5. Well, now I have an equation that doesn't have any variables. And I just have negative 2 is equal to 5. Well, is that a true statement? Is negative 2 the same thing as 5? No, it's not. So this means that negative 2 is not equal to 5. So because the variable canceled and we're left with a false statement, no variables, false statement, that means that there is no solution. And instead of writing out the words no solution, you can use the no solution symbol, which is just a 0 with a line through it. This means no solution. So now that you're in Algebra 2 and you understand that this symbol means no solution, you are not allowed in this class to write your zeros with a line through them. Some people write like the number 10 like that. You're not allowed to do that in this class. Nope, 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 nope. Because this means one no solution. What does one no solution mean? So if you need to write, you need to get out of that habit and just write your zeros as an oval. So what does no solution actually mean? What does it mean for an equation to have no solution? Well, no solution means that there is no value that you could plug in for y in this equation and get a true statement. You can try plugging in any number you want and none of them are ever going to work. So there is no value that will make the equation true. The equation is always false. Therefore, this equation has no solution. So your very first step should have been to combine the like terms of 2z and 2z, which gives you 4z plus 2 on the left side is equal to 4z plus 2. Well, is 4z plus 2 the exact same thing as 4z plus 2? So aren't the left-hand side and the right-hand side of this equation already the exact same? They are. So you can actually stop there if you understand that, or you can keep going. So what if you subtract 4z from both sides? Well, 4z minus 4z cancels. I'm left with 2 is equal to 4z minus 4z cancels again, and I'm left with 2 on this side. Well, 2 equals 2. Is 2 equal to 2? Is that a true statement? Yes, it is. Well, we could stop there, or we could keep going and subtract the 2 from both sides. Well, we get 2 minus 2 is 0, is equal to 2 minus 2, which is 0. 0 equals 2. Well, again, we are left without any variables. So there are no variables left. But this time, is 0 equal to 0? Yes, it's a true statement. So that means that this time we have infinitely many solutions. Infinitely many solutions. Well, what do you think infinitely many solutions actually means? Like, that's a bunch of words, but what would infinitely many solutions actually mean? So what it means is that no matter what value you plug in for the variable, you will always get a true statement. So what does it mean for an equation to have infinitely many solutions? It means that any value can be plugged in to the variable and still make the equation true. All right, so now we're gonna go ahead and start talking about example 4. So example 4 is our first word problem of the year, yay! All right, so it says that flower carpets incorporate hundreds of thousands of brightly colored flowers as well as grass, tree bark, and sometimes fountains to form intricate designs and motifs. One such rectangular flower carpet from Grand Place in Brussels, Belgium, has a perimeter of 200 meters and side lengths that measure x and 3x. What are the actual dimensions of the carpet? So to find the dimensions, we need to write and solve an equation. To do that, we need to look closer at the word problem. Now, one thing you always need to be wary of is that word problems always have excess information that you don't need to actually solve the problem. In fact, that whole first sentence is just kind of extra and unnecessary. It doesn't give us any details of the problem itself. It just gives us background, like context, essentially. Now, the first important part is that we know that it's a rectangle. So I'm actually going to draw a rectangle. I think drawing pictures when I have to solve word problems helps me. Highly recommend. Where it's from doesn't really matter. Has a perimeter of 200 meters. So we know that the perimeter of this rectangle is equal to 200 meters. Okay, the side lengths measure x and 3x. So the shorter side would probably be x, and then the longer side would probably be 3x, since it's 3 times as long as x. What are the actual dimensions? So how do I find the perimeter of a rectangle? To find the perimeter of a rectangle, don't I add up all the sides? So I'm gonna take side x plus, well, if this is x, so is this side, plus the other 2 sides. So if this side is 3x, then so must be the opposite side. So this would also be 3x. Well, I know that the perimeter is equal to 200, so I'm gonna replace the perimeter of the rectangle with 200 is equal to x plus 3x plus 3x. Well, x plus 3x plus 3x is equal to 8x. Divide both sides by 8 to get x by itself. So x is equal to 200 divided by 8 would be 25. But this is a word problem. And we just found the length of one of the sides, which means this is a distance. So what unit are we measuring this in? Well, if the perimeter was in meters, so would the side lengths be in meters as well. So x is actually 25 meters. But because this is a word problem, you need to answer the question in a complete sentence. And the question wants the dimensions of the carpet. So we know that if one side is 25 meters, how long would the longer side be? Well, it has to be 3 times x, or 3 times 25 meters, which would be 75 meters. So that means that the dimensions of this flower carpet are 25 meters by 75 meters. And that would be your final answer. So anytime you have a word problem in this class, you're always going to write your answer in a complete sentence. Let's move on to example 5. So in example 5, we're solving a literal equation for an indicated variable. So what we have is c is equal to 5/9 times f minus 32. And we need to solve it for f. So I'm going to solve this thing for f. Well, normally parentheses mean multiply, and we would distribute the 5/9. But there's something that we can go ahead and do to get rid of the 5/9 and move it to the other side that I think will be more helpful than distributing 5/9 to f and 32. So what we're going to do is we're going to cancel the fraction. Well, what does this fraction bar really mean? It means division, right? So 5 is being divided by 9. So how do I cancel divide by 9? Wouldn't I multiply by 9? Then 5 is being multiplied by this. How do I cancel multiply by 5? I divide by 5. So what happens if we multiply a fraction by its reciprocal? Well, what's 5 divided by 5? It cancels, right? What's 9 divided by 9? It also cancels. But what I do to one side, I have to do to the other. So don't forget to also multiply this side by 9/5. So that side of the fraction is f minus 32. And then this side becomes 9/5 times c. It's as simple as that. Now add 32 to both sides. So f is equal to 9/5 c plus 32. Or you can write it as f is equal to 9/5 c plus 32. Either way will work. And there we go.